So, hello everybody. My name is Kai Hackbarth. I'm with Bosch Software Innovations in Cologne, Germany. I'm here with Pavlin.
Yes. I'm in Bosch Software Innovation from Bulgaria, and we will together will talk about OSGi and IoT market. Our presentation is not so deep technical, and I suggest if you have any questions, just to stop us, ask us. I really want to have a discussion, not only the presentation, and for sure we will try to keep in time in order to have beer after the end.
Right. Okay, so we've also started a little bit at the beginning. So basically when it all started at OSGi Software, that was a company that Bosch acquired in 2015. So almost 20 years ago, we already had an OSGi implementation. We already had to focus on smart homes, smart vehicles, and so on. And we were really one of the few software vendors that really did something in this area. And the term Internet of Things was basically not invented then. Yeah, it started in 2005, 2006, and was mainly used in the scientific research community. And when we were talking to, be it smart home gateway vendors or even car companies for opening up their platform or their systems, it was really scary to them. That was like, we don't want an open platform. Yeah? And then especially in the smart home domain, everybody was looking for a killer application. So something like SMS, yeah, and they wanted to have it for a smart home. Obviously, nobody has found such a killer application even until today, yeah. And that basically prevented that companies were investing or even finding business models, yeah. And then we also had sometimes the cases that some of our customers actually, we developed something together with them, and just before the launch of their product, they decided maybe it's too risky. Let's stop it here. Yeah. So we had all kinds of experiences. Let's say it this way. Yeah. And in summary, I would say we were offering a solution to a problem that did not exist back then. Yeah. So today, that's very different. Today in the IoT world, we talk about platforms and ecosystems, and there is a nice report from a German company, IoT Analytics, that basically makes an overview of all the IoT platforms. And last year, they counted 450 IoT platforms. So it's not all the same, right? So some of them have the focus on big data, some have the focus on embedded gateways, whatever, right? But it's huge and it's very confusing, especially for those who actually want to use IoT. And then just to say it also, it's 90 more than in 2016, right? So it's almost scary. And then in the IoT domain today, it's really like you have to deal with all kinds of domains. Yeah? So when we started in 2001, as I said, smart home was a bit the focus, smart vehicle, we were also talking about healthcare, but that's not really, very serious. Today it's really everything. Yeah? It's energy, it's industrial IoT, it's smart home, it's healthcare, it's smart vehicles, all the things you can imagine. And then you have to deal with a wide range of devices. So be it simple motion sensor, or an industrial machinery somewhere in a plant. Yeah? And we'll talk about this a little bit later about device abstraction. Device abstraction helps you a little bit to, let's say, deal with the pain that comes with integrating different devices, but it's only taking part of the pain away. It's not let's say a complete solution. And what we see is that the complexity is still increasing. Yeah? So due to the fact that we have so many different IoT platforms and nobody yeah, is going to say, let's say, you know, smart home, or let's start it differently. So smart home is, you could say, part of, you know, smart grid. Smart grid is part of a smart city, yeah, and there will be no single vendor that will provide the solution for this entire ecosystem, right? So we have to find a way that all these different, you know, solutions find together. So, and the next slide is basically just visualizing. Unfortunately, that's the latest IoT landscape, yeah. And you see the amount of companies that are doing whatever, yeah. And I think this basically visualizes the need for standardization, right? And that's exactly what we do in OSGi. All right. Do you want to do this, or shall I?
Yeah.
All right. Okay.
You read the.
No worries, no worries. So, so this is what we also did since a while, actually. So in 2008, I believe, we founded inside the OSGi Alliance the Residential Expert Group, which is basically, now we have the IoT Expert Group, which is kind of the successor of the Residential Expert Group, if you want to say. And in 2012, we published our first specification, and the focus was really on how to do remote management on OSGi smart home gateways. And we did this not just alone, we worked together with several other consortia. One is HDI, that basically helped us to, you know, to push this into the market, because they basically defined a document that you know, the telco operators used for RFPs. It defined how to use modular software architectures in home gateways. Yeah? And they did not just say it's, let's say, OSGi specific, but they had an OSGi specific part. And in the end, there were only OSGi implementations of this. Yeah? And then we also work together with the Broadband Forum that, let's say, defines a management protocol for the telecom operators, but that's broadly used also today in generally all smart home environments. So then in 2015 we had the release 6 specification of the Residential Expert Group, and here was a focus more on how to, you know, deal with devices. Yeah, so we had a specification for in-ocean, for USB, for you know, communication with devices via the serial port. We were dealing with the device abstraction layer, and the device abstraction layer basically tries to abstract devices from their protocol, so that an app developer, yeah, if you want to build an ecosystem, that an app developer doesn't need to be an expert in the different protocols. So he doesn't bind his application to one protocol. Yeah? And that makes it basically easier for everybody. Yeah? So he doesn't need to know how to switch the light on using the ZigBee protocol. Yeah? And at the same time, he doesn't need to know it for Bluetooth, yeah? Because we basically take away the pain for him. And there were some other specifications that I don't want to mention here because of time. But so this is just to say, you know, we have been working in this domain, I mean, in the OSGi Alliance since 2008, and it's already in use. I can just say for Bosch, our gateway software is already being used in approximately more than 1 million smart home gateways today. Yeah? So we talk about, let's say, some serious adoption here. Yeah?
Even in Bulgaria, you can go to Plexio, buy from them some device, and you use our gateway, implementing also this specification.
Right. Okay. Do you want to do this?
Yeah, I suggest. Kai said in the beginning that it is not so easy to have one platform. Currently we have 450 different platforms, and it is not so easy to have one vendor that, like Microsoft, that do the IoT platform. And in the beginning for the Bosch, it was very important to say on the strategic level that no one can do IoT alone. So this was the reason, and this is the way how we do the thing, to be maximally open regarding the Eclipse Foundation. We are one of the strategic membership of the Eclipse. And also we have more than 10,000 developers that deal somehow with Java and the Eclipse. Regarding Bosch, we have much more developers, but most of them are concentrated into the real embedded stuff. And after deciding going to the IoT, the focus was IoT industry working group. And the real problem with the stuff when we go to the real devices, this is the long-term support. If you have one fridge or one microwave, you use 10 or more years. You have inside lots of software. And in order to provide such kind of stuff, you really don't need to care not only regarding the very cool architecture, but also regarding the stuff that will be supported over the time. And also participating in the Eclipse and doing the stuff open source help of us a lot, because we have not only Bosch doing the stuff, but we built ecosystems that we are just one of the participants of this ecosystem. Currently we have several projects inside the IoT working group that represent different use cases regarding the IoT ecosystem. I think that every one of you have heard about the digital twin pattern, and Eclipse D2 is the implementation of this digital twin pattern. Eclipse Hobby, this is the one use case that is really important. In most cases, you need to deliver something to your device. When you sell the device, you need to do some kind of firmware upgrade, software delivery, and so on. For example, one car have more than 15 megabytes of software, and you need to find a way how this 15 megabytes to be delivered in the efficient way. And you need to have a special procedures for delivering. You need to have a worldwide infrastructure with content server or stuff like that. And Eclipse Hobby solves similar kind of stuff. Eclipse Hono is like a middleware that acts as a hub between the different kind of application. I think that we are working very actively with Red Hat in order to implement that. Just some kind of message brokering that receives the messages from the different kind of the devices, and after that scales these messages to the different kind of services.
Yeah, think of it as the Azure IoT Hub, just in open source, right? So.
Absolutely. Regarding the SHAN, this is the lightweight M12. Maybe you know that MQTT is just a message brokering. In order to do the remote management, you need a much more complex protocol that defines the abstraction of the management. It defines the management object, what exactly needs to be management, and also lightweight M12 is enough lightweight in order to be put in the small devices. And I think that Kai already mentioned the device abstraction. Eclipse Work is a very good implementation of the device abstraction itself. It defines the information model, and you can model the different kinds of devices. And after that, this kind of information model sits in the repository. Using this repository, we can, using the different kinds of code generators, we can generate, for example, interfaces for Eclipse Smart Home, interfaces for some private stuff, and so on.
Exactly. And this is a missing part that I was mentioning earlier, because this basically brings you the semantics. Yeah, this gives you the description of the devices and so on. And I mean, you don't have to really, you don't need to be a developer in order to use this. Okay?
Yeah, if we have, for example, one sensor, we have lots of semantic information inside this sensor. You need to deal with the metric system, you need to deal with exact kind of data in this sensor, you need to deal with the software update and so on. And this is the way how it is described. Okay, maybe you.
All right. So, I mean, as you see, and this is the Bosch here, we try to, let's say, combine basically best of both worlds, from the open source world, from the open standards world, right? And obviously there are pros and cons for each, let's say, way, obviously open source, you do not have a license fee. You have a relatively easy way of, let's say, modifying the code depending on, let's say, the license, right? It usually, I mean, if there is a community behind it, it's publicly tested, and you have sort of a community behind, or support from the community also. Contras are, service level agreements are not possible in the open source world, right? Like you need to be, let's say, careful about potential license violations, not just that you can, use, every open source project and, put them together and be happy, right? So licensees may be incompatible, and that, can cause you lots of legal issues. Modification follows license regulations. On the standard side, we have specifications, in most of the cases free of charge, right? It enables interoperability, that's exactly what OSGi is doing, right? And you may have different ways for licensing this, So, I mean, you find OSGi in different open source communities. So there's a Felix, there is Eclipse Equinox, Eclipse Concierge, there's Knopflerfish, and you find also several commercial implementations like from Bosch. And also here there is a large community, right? So we try to bring, you guys together with, the rest of the OSGi community. It does have also some contras, obviously. Modifications have to follow the specification process. It's, let's say, not as fast, obviously, as, in the open source world, where you can just, do whatever you want, right? Oh, wait. That's, let's say, provocatively said, right? So, and obviously you need to be a member in order to influence those specifications. And I think about the closed source solutions, I will not just, let's say, mention this here. So again, our message is we try to combine best of both worlds.
And just to add one sentence, that colleague usually joking, which is good to have in the development team who are in the beginning when we deal with the open source. Sorry, but this is the real problem, because currently here is 1,000 different kind of licenses. Everyone wants to include something, and in order to prepare, how to say, disclosure document, you need to do a lot.
I mean, okay. the overhead we have, for quality management, right? I mean, source code checks and everything, it's just insane, but if you want to do it right, it's what you have to do, right? So.
I will not focus it big amount of
exactly. The point here, I think, is just that this is how we bring it all together. So there's, let's say, the Bosch IoT suite, and this brings basically, the gateway software where we have our OSGi stack in. And then there is, the, let's call it the cloud side, of it, where we use a lot of open source projects.
The idea is to have, how to say, lots of building blocks. Even the open source, almost everyone can assemble it. And if you want to connect some device, you need to write some small logic here, and also you can directly use high-level services using the REST interface that provide such kind of use cases that I already described, like software provisioning, device management, team, and so on.
Okay, and this is also just, let's say, how this looks end-to-end, right? So the gateway software being, let's say, the focus here, so this is where we use OSGi, and so what we really care about is, how to bring all these different, let's say, protocols together, with the device abstraction layer as mentioned before, yeah, and also on how to, let's say, manage the gateway software, but maybe even also the edge devices itself, right? So, I mean, especially in IoT, yeah, security is obviously a problem that you have to face all the time with. Updates are, you know, coming also all the time. For example, in vehicles you have map updates, etc., etc. So you always need to, let's say, be able to manage the, let's say, the entire environment there.
For example, in vehicle we use almost every new vehicle connect at least once a week in order to get the map updates, stuff like that. Almost every new vehicle have ecosystem in order to send an SOS or stuff like that, and it will be required by the new cars. I think that one of the best-selling products of the Bosch is the one small dongle that realizes the ecosystem currently.
Exactly, it's actually for cars, for older cars that basically can have an e-call without, let's say, any modification to the car itself. You just plug it into the vehicle in the, you know, for the fire, I don't know what it's called in English, yeah? So you just plug it in and then, you know, it will detect automatically when there is an accident and call, you know, not the hospital, but, you know,
I think the Bosch
ambulance,
center
right? So,
calls,
yeah.
For the Bosch devices.
Anyway, so this is how the gateway software looks like in more detail. Yeah, I think we should not go into all the different details here. Again, this is just a different view. And again, so what really matters a lot is, you know, all the different, you know, protocols. Yeah, that's you know, in IoT, basically, you know, the core business that we do. And it's also universal, so we don't focus on any specific IoT markets. And then there are lots of, you know, standard services that OSGi defines, and then again this device abstraction layer in order to, let's say, build an easier ecosystem.
Yeah, from a programming point of view, for example, if we have a lamp, it will be OSGi service lamp inside the OSGi registry, and plug and play mechanism of this abstraction. If you put ZigBee, Z-Wave and so on lamp, it will be the same Java object. We will say just on, off, set brightness, and so on.
Okay, so this is just again what I mentioned earlier. We don't go into details. So we really don't focus on a specific IoT market. We do it, let's say, basically all. And maybe to pick one example is in the agriculture, so oyster farms. So those guys, they have, especially in Australia, they have issues because those oyster farms can be, let's say, closed by the government after rain because the water is kind of poisoned, right? So what they want to have is a way to basically analyze, you know, the water, yeah, what the condition of the water, and they also basically want to have, like, you know, a 3 or 4 days forecast, yeah, on how it's going to develop. And for this, they basically deploy a couple of sensors that talk via LoRa to a gateway, yeah. And then there is basically some magic, you know, in the cloud that is doing some machine learning, artificial intelligence magic, I would call it, right? And that basically generates you this forecast. And this really actually helps those oyster farmers a lot in order to save their income, right?
Maybe I can share some experience. This is Intel board, and it is inside the sea. And it have no possibility to connect to the electricity than the solar panel. And the solar panel in the sea are not so very effective. So you can have maybe 5 minutes per 1 hour. Just so you need to put the board, do some magic like Kai say, send the stuff to the Azure cloud, and after that you sleep for period of time to get an energy. After that, do it again, and so on. So you need to deal not only with the programming, but also with some how to say, mechanical and stage stuff. Also regarding the oysters, they are very good, but if you harvest when there is a particle in the water, this is the real problem with the rain, we cannot treat it. And normally, if you use only the forecast, maybe you throw away 30 or more % of this oyster that you already harvest. With such kind of expert system, we achieved around 95% of the oysters in order to be possible to be harvested and used directly. And when you say IoT, this is just, how to say, the very strange example of the IoT, but the colleagues are very good regarding the implementing the stuff. Also, some of the colleagues traveled to Australia in January, and it was sunny beaches and stuff like that. This is also very good.
All right, so then let's finish this presentation. So why OSGi? So as I said in the beginning, so we do this since 1999. So basically, Moses back then joined OSGi Alliance directly after its foundation. Yeah. So and this has really been our core business since then. Yeah. So I mean, we have basically two core products, yeah, that have evolved over time using OSGi, right? Obviously, I mean, doing OSGi-based applications, you know, it can be difficult, yeah, especially when you're not, when you're new to modularity in general, right? So there is, I think, in the design phase, you have to invest more time in order to do it right, yeah, but it will pay off later, yeah. And especially, I mean, we have always been, let's say, experts in the embedded world, yeah, and in the embedded world, I think it pays off rather quickly because you have a high variability in embedded system, meaning you have different CPUs. There is not just, you know, Intel x86. There is MIPS. There is ARM. There is more. Yeah, you have different OSs, different Java virtual machines, and so on. And so you need to be able to deal with this. When you do, let's say, OSGi, right? Yeah. So code reusability is obviously one of the big advantages. Think of it in cars. Yeah. So if, for example, Mercedes, the A class to S class. Yeah. So basically you have one standard stack. Yeah. And then there are always additional features, you know, per vehicle. Yeah. So I mean, if you want to do it right, that would be the way, right? So. And then you also need to be able to deal with different software configurations, right? Remote management, which is obviously, you know, also a core feature of OSGi, is completely standardized, yeah? And then also the device abstraction layer really, let's say, helps with certain issues, not with all of them, yeah, but discovering, controlling, querying, eventing, management mechanisms are all there. So developers don't need to be expert in all the different protocols, right? So that also takes a lot of pain away. And as we said before, because of this, IoT applications, whatever this may be, you know, they work on the same type of devices, yeah, even if they use different protocols, yeah. So I don't know if you have any last words.
Yeah, if you have some questions, we can answer regarding that. And also I want to answer one question that was asked in the beginning regarding unloading of classes and some of the forbidden stuff. In the enterprise world, this is not possible, but usually in the embedded it's possible. You have embedded virtual machine, you have unloading of classes, you have memory spaces, we even have support of the multiple VM. One part, for example, the driver of some device can be the separate process and stuff like that. When you design the application, you need to think about that, because OSGi bundles cannot be only in the one process. You need to, how to say, to have some stuff like reliability, security. I also remember the BJ say that the security is optional, but we are always pushing the security. Even in the first version of the specification, I remember that we tried to implementing lots of the security stuff inside the OSGi.
I have a question. Basically, this is the same question. Why OSGi? But I'll develop it a little bit more. I don't think that OSGi was created and developed the last few years, and not few, 20 years maybe or more, just to enforce modularity. I mean, that's a great thing, but it's not the killer feature of OSGi. Why really OSGi besides modularity? Or maybe what are the added stuff that I have from the modularity implemented in the OSGi way?
Not so easy, maybe it's some kind of political question.
Yeah. I mean, obviously OSGi is doing more than, modularity, but modularity was, I guess, the beginning, and I would say has always been the core of OSGi,
sure.
Right? So, but yeah, today we do a lot more than just, dealing with the modularity, yeah? So, I mean, especially in the IoT domain, right? We deal with many different aspects just than modularity.
Yeah, also in the beginning, I was very active participant in the first NATO specifications. The name initially was Open Service Gateway Initiative, and the idea was to define the whole platform in order to have applications running on top of the gateways. And the first version of the specification focused on the functionality. Second version of the specification focusing on the security. Third version of the specification focusing on the device management. After maybe 10 years of developing that, we are focusing on the different domains. We started doing stuff like the Kai group residential in order to have the residential. For some point of time, we have a telematics working group that was very active defining the interface of the telematics. Currently, OSGi have IoT working group that focuses. Currently, OSGi is not just specification for modularity. It was maybe first few years. And I think at some point of time, maybe around 2010, someone checked that almost 70% of every Java application uses OSGi somehow, but on the lower level. Almost all the IDs, all the application server, and so on are built in the lower level using the...
I mean, we just found a generic way, right? So, I mean, that can be used from embedded system to, all kinds of, environments, to application servers, right? So I don't know if BJ, Dan, want to say something specific to this question? I mean,
I guess from my perspective, BJ and I have been with OSGi since. I'm Dan. You've met BJ. I'm Dan Bender. I'm the president of OSGi right now, and I've been on the board of directors since it first formed in '99. And as you were saying, a lot of stuff that originally was coming out of the telco industry and telco suppliers and deployments for home premises equipment. And back then we had very resource constrained devices. I mean, my iPhone has about 1,000 times more power than the gateways did back then. And that's not an exaggeration. And so we needed a way of partitioning software in an efficient and robust way, right? And so that it was a difficult problem. How do you partition software up and and make it very robust? And so that's where we started. But as you were saying, we went into a lot of other domains, and those domains forced requirements on OSGi that actually expanded its usefulness. And so, as I think you mentioned, many of the application servers out there in the world, like I'm with IBM. Our major Java EE application server is OSGi modules from the ground up. And we actually last year released a subset of it as open source. It's 3 million lines of open source out on GitHub. You can go look at it. It's just one big application. It's a huge application server, but it's all OSGi modules. And Glassfish, which is Oracle's reference implementation, is also OSGi modules, and it's being moved over to Eclipse now. So, what OSGi really ended up being and I wish I could say back in '99 we were so brilliant that we could see, years into the future and know exactly what we were going to do. But what it turned out is it was a really good idea for good software engineering. Isolating things, decoupling different things, and made it very much easier to maintain and build software. So going back to the WebSphere application server, because that's what I'm most familiar with, that's what my company is a good example, is when we first started, before that, we had millions of lines of code, and it took us it literally took over 2 years to do a new major release and make sure that it was super reliable, super robust, because when people came to IBM, that's what they expected of our software, right? Once we got it turned into a bunch of OSGi modules, we went from that 2-year test cycle to what we now release on a quarterly basis, new features. And one of the reasons is we can do that is because the isolation that we get with the modularity allows us to do very robust things and not break stuff. The coupling that used to cause us nightmares, you change this one little thing over here and break something way over here, that just doesn't happen anymore. And so, we could go on and on about this, but the net of it is, it turned out to be a really good software engineering practice to have enforced modularity. And when you build something, the more complex the thing you're building, the more you're going to benefit from modularity in OSGi. And if you're going to try to assemble things from a lot of different sources, I think Tudor's presentation sort of went into that. With versioning and isolation, you can actually pull from multiple things and not worry about collisions, because like if you've got a logging service over here from an open source project and you pull a project in that uses that logging service, and then you go over and grab another open source project, it uses the same logging service but a different version. Well, it used to be old class pack hell, right? And somebody was going to win, somebody was going to lose, and it's not going to work. Well, with OSGi you can isolate those things, right? And that, in a real-world environment, makes software engineering a whole lot easier. I'm done.
Maybe we remember that class in Java depends also on the class holder. So using the OSGi, you can load even the different kind of the same library, isolating the subsystem, and this is the way that realize it in the program.
With the encapsulation of the modularity and the semantic version, it enables you to make a promise to your future self that you can keep, right? Because without that, you can't ever make that promise to your future self or to others, right? There's no way to know, and so all you have is testing, and of course that just goes on forever. So with enforced modularity and semantic versioning, you can make a promise and test against it.
I mean, just think for a minute of how many lines of code are in the projects or the platforms that the 3 companies who presented tonight have in their code bases, in their environments. We're probably hundreds of millions of lines of code, and then the raw investment does not permit you to have the freedom to throw that away. You need to be able to reuse it. It's your core investment. There's no other way to engineer a system for long-term use. Like, these guys have been building platforms and applications for over decades and evolving their systems, and I mean, you just couldn't have done it any other way. You would have thrown away so much technology over time. It would have been so costly over time, and that is the core value. That is the killer feature of OSGi. These guys and our company as well. It's much smaller, but the idea is you can't afford to build a product that can only last 6 months. You can't. It's completely unfeasible and irrational to think that way in software, and far too many people in our industry think that way. The killer feature of Java is that, or of OSGi, is that it's possible to do that. It's possible, no, not to, it's possible to think 10 years into the future with OSGi. Try to do that with other technologies.
Also, Software AG, I mean, the foundation of their platform is OSGi. So it's...
May I add something which may be when you have this modularity thing, and a simple way to exchange services based on pure business logic, but it enables us to have a whole suite of specifications for enterprise, for example. So we really cover everything. We have dependency injection framework to agree, we have transactions, we have JAX arrays, CDI, the whole business suite you might need from different vendors, different open source projects, interchangeable, right? In your own code, it's highly reusable because it really couples only to APIs, right? This is how this killer feature we talked about underpins a whole complete, at this point, ecosystem of specs, which are actually integrated with open things from the J2E world. And the gaps that are filled are simply things that are genuinely missing and work really well in OSGi. So you can go and look at the OSGi enterprise documents and basically look through the suite of things you might need. And we actually have presentations that show that really complete. Actually, we have a project our companies develops, all of us, but we continue to recently called it on route, right? Where we can go in 15 minutes get up a JAX OS microservice with transactional support, all notation free, right? So this is when you dig down why this works, you end up to these basic properties that I talked about. Right? You can equally define the coupling on both class level and object level, nothing special. Right? We're getting the same simple textual ways to match things, so that any tooling can understand it, not just the developer who writes code. Right? So yeah, that's it.
All right. Any more questions? Doesn't need to be to us, so maybe also to the entire OSGi group here.
Maybe it's a good idea to grab some food and beer.